Okay, students, now we are going to discuss the crypt analysis of the Caesar cipher. In the previous video, we have seen that how the symmetric cryptography can be done by using Caesar cipher. We have plain text and we use one encryption standard, and we have a secret key as 19, and we have sent this the encrypted message over the this channel. And at the recipient side, we have decryption algorithm. In the Caesar cipher, we have subtract the key from the cipher text, and we get back the plain text. So in this section of our lecture, we will discuss the crypt analysis of Caesar cipher. So for the quick revision, I am going to write the definition of crypt analysis. What was the crypt analysis? That was the breaking of code without knowing a key. So the concept of crypt analysis is that we don't know the key, and we have a ciphertext, how we can break it, what kind of combination and keys we can use. So students, for the understanding, for the sake of understanding, I am going to share another slide with you. That is the crypt analysis of Caesar cipher. So this example shows that how we can use the brute force attack for the decryption of Caesar cipher. So what the brute force actually is? So the definition of brute force is try all combination of keys. Try all combination of keys. For understanding of this message, this technique, suppose we have only four binary numbers as the plain text, and we have converted into the ciphertext. So if we have four binary digits, what we will do, we will start it with the 0000, and we will keep on adding it 111 up to all ones. So this is the technique where we use all possible combinations for every character in the field. So this is the binary number. There we can have all zeros, then 0001, 0011, and up to all ones. But in the Caesar cipher, and we already have discussed that the field is 26. So all numbers must be in the field from 0 to 25. So what we can do, we can use all the keys from 0 up to 25. And we can see here in this example, we have tried the 45 possible keys and come with the very meaningful message, that is meet me after the toga party. So we have decrypted it without knowing a key. We use 0 to 25 all combination of keys, and we have seen here that if that is breakable if we don't know any key. So this is very basic crypt analysis, and a brute force attack is a very famous technique for breaking the code. People use dictionaries and online different websites and tools to try all possible characters in the relevant field to decrypt it. That is the first step of the attacker to decrypt any message or any server by using the brute force attack. So for the sake of simplicity, you must know that in the field of cryptography and network security, if we have any encryption algo, suppose that is f of x, there must be some f dash x that can be used to break this code. F dash x. So mathematically, this is possible that once there is a technique for encryption and create the security and privacy of the plain text, there will be the crypt-analysis of the algo as well. So we need to develop such complex algorithms that are time consuming and secure and mathematically and statistically unbreakable. So after the Caesar cipher brute force attack understanding, we will come up with a new algorithm that is called as multiplicative. So students, in this slide, I have written the algorithm for encryption and decryption in the multiplicative cipher. Here you can see that the algorithm is similar as a Caesar cipher, but one thing is different, that is the symbol of multiplication. In the additive cipher or Caesar cipher, what we use instead of multiplication, we use addition. And here we can see that in these for development of this cipher, we just need to multiply the plain text with the k, and we will have to take the mod 26. But for the decryption, we have to multiply it again with the k inverse. So this k inverse is actually in the modulo field of 26. So this is the complex part of this algorithm. So let's discuss it with the very simple example. In the modulo arithmetic, we have a property that is a multiplied by b mod n. If we have two numbers with the model n, then we can write it as a mod n multiply by b mod n, and again we need to take the mod of complete numbers with the n field. So in this, according to this statement, we can break over decryption part of this algo. What we can do, we can use as c mod 26 will be the separate part of my algo, multiply by k inverse mod 26, that is inverse, that is the superscript mod 26, and we need to take another mod 26 of the next number that will be multiplied with the field. So this statement is now converted into the multiple of 2 modulo, and according to the modulo arithmetic, we can see that we can calculate the both mods, and we can take the mod 26 in this respective field. So this is the difficult part of this algorithm. With the help of one example, let's discuss it. And before proceeding with the example, let's come up with the solution of k inverse mod 26 field. So students, in this slide, we can see the formula of finding the multiplicative inverse in modulo n. So according to the formula, what we have to do, that if we want to find the inverse of any number in mod n by using the finite field, what we have to do, we have to actually multiply it with such integer that is congruent to 1 mod n. This symbol is called the congruence. So for the congruence, we need to find this tricky number. When we will multiply it with the key and we divide it with the n, the answer or remainder should be 1. So for the simple example, I have illustrated here that 7 inverse mod 26. So the tricky question here is, if we multiply 7 with 15, that is 1, 0, and 5, and when we will divide it with the 26, it will become 104. And the property of this algo is now correct, that we have 1 as the remainder. So this is the tricky question. For the smaller number, we can do this calculation, but for the larger numbers, we have one algorithm that is called the extended Euclidean algorithm for finding the multiplicative inverse. And in the coming chapters and coming examples, we will discuss it in detail. For the simplest multiplicative inverse, that is enough. We need to find different multiples of 7 or of the key, and try to get such number that the remainder of the division is 1. So after the property, what will be the inverse value? Actually, the A, whatever you have find this number, that is actually the inverse of that number. So according to this example, 7 inverse mod 26, the answer of this question is 15, this tricky question, this tricky number. So importantly, there can be, this is also one possibility, that we can have multiple inverse numbers in a respective field. That means we can have different numbers when we take the mod of that number. With 26, we can have 15, we can have 17, or etc, etc. So this can be possible, that we have different numbers in the calculation. So now I'm going to show you one example for understanding of the multiplicative inverse. So students, after the calculation, we have seen that Khan is actually 10, 7, 0, and 13. We have multiplied it with the key that is already given, that is 19. After the calculation, the resultant numbers are 8, 3, 0, 13. That is IDAN in the ciphertext. In the encryption part, we just have to multiply the plain text with the secret key. On the decryption side, we already have known that for the decryption, what we have to do, we have to multiply the ciphertext with the K inverse, and then we have to take the mod 26, as I have discussed previously. So here the tricky part is this single statement, that is -1 in mod 26. So after the calculation, 19 inverse mod 26, that is actually inverse function. So 19 inverse mod 26, after the calculation, I have find a tricky number, that is 11. When we multiply it with the 19 and divide it with the 26, the remainder is 1. So we have 11 as the inverse of 19 in the modulo 26. So now the end of the question is relies on this number. Now we just have to multiply 11 with all the characters in the ciphertext, that IDAN. We can see in the key matrix that I is 8, D is 3, A is 0, and N is equals to 13. And I have just multiplied it with the 11 number, and then have take the mod 26, and we can see here that is the Khan that was actually the plain text in this question. So in the multiplicative inverse, both in encryption and decryption, we can see that is 19, the similar key for encryption and decryption. Again, you can see one more thing, that that is monoalphabetic cryptography technique, because one character is mapped with the one other character.